right. So we left off. We did we get to number? We got through third. No, we got through 13, did we?
We got through 11.
We got through 11. Okay. So we're on number 13. Question number 13. Okay. 13, 15. Three more of these longer questions. I want to get some short questions. Okay. So number 13. This is on section 4-4. Logarithms. Okay. So they give us on number 13. They want you to change it to exponential form. Okay. So on part A, it says the log of x equals 50. Okay, you're not figuring anything out here. They just want you to rewrite that without logs. They want you to write it as an exponential function. So if you can, thank you. If you can come up with, if you can understand this right here, if I give you this right here, the log, for example, base 2 of 8 is 3. Okay, that's a true statement. The reason why the log, the way you read it, base 2 of 8, and that might be a question on your next test. It very likely will be. It might say, write that out in words. Okay, and in words you would say the log or logarithm base 2 of 8 is 3. Okay, I may ask you that. Write it in words. Okay, you gotta be able to say it. So some students say log 2 to the 8th power. No, that's not even close. The log base 2 of 8 is 3. Okay. So what you need to understand is this is the little number, the subscript number is your base. Your base is what's raised to the power, okay? 2 to the 3rd is 8. So here, I don't see a base. We talked about it briefly on Friday. It's 10. It's called a common log, okay? So 10 to the 50th equals x. That's it, okay? And you don't need to simplify. Actually, it is pretty easy to simplify. I wouldn't want to write it out, though. It'd probably dry up my marker. You know what 10 to the 50th is? A 1 with 50 zeros after it, okay? That's a humongous number, okay? Part B. They don't want you to do that anyhow. They just want you to rewrite it. So on part B, our base is 10. 10 to the 20t equals x. Now, ln x, that's natural log of x, is 0.1. Natural log, you guys remember from Friday? It's not base 10, base e. And how do we write e? Is it capital E? Lowercase e. So e to the 0.1 equals x. Hopefully you find these pretty boring because you might think, what's the point? Okay, they just want to make sure you know the rules so you can use them later on. Okay. For part D, again, it says natural log, so it's going to be log base e. So e to the 4 plus 3x, and you got to be careful. Well, I would put it in parentheses, so it's all of that to the power equals w. Notice one more thing. Let's stop here just for a second. I'll let you guys catch up. I just want to make sure you guys understand this. You don't need to know this, but it kind of makes it a little bit nicer. A lot of times students really struggle with logarithms. I want to show you a little trick that might help you out. Notice when it's written with logs, look back at part A. When it's written with logs, see how the 10 and the x are together? They're right next to each other. When you rewrite it, what's together, the 10 and the x, splits up. The things that are together split up when you rewrite it, okay? In part E, so it says natural log, so base e, e to the 1/6 equals z minus 2. Okay? Any question on that? So number 15, find the number if possible. So they want the log base 5, oh, that looks terrible. Log base 5 of 1. Okay? Log base 5 of 1. Now if you're not sure what it is, rewrite it, okay? Our base is 5. 5, they're asking 5 to what power? Is 1. 5, you don't have to rewrite it like that, but if it's easier for you, rewrite it. 5 to what power is 1? This is an easy one as long as you remember it. 5 to what power gives you 1? How many remembers?
Oh, 0.
0, why?
Because anything to the 0 power is 1.
Good, so this is the number 0. This is the number 0. Part B. Log base 3 of 3. Be careful on this. This is a very simple question and a very simple response. It's also very simple to get the wrong reason behind it. Okay, true or false? Is the answer 1?
No.
It actually is 1.
Oh, no, I thought you said 9. Whoops.
No, that's a 1. Okay? It's 1. True or false? It's 1 because 3 times 1 is 3. Wrong. 3 times 1 is 3. But it's not because 3 times 1 is 3. It's 3. 3 to the first power is 3. And again, 3 to some power is 3. You don't need to rewrite it like that unless it makes it easier for you. It's not because 3 times 1 is 3, it's because 3 to the power of 1 is 3. C. This is a tricky one. Log base, oh wait, no it's not. We haven't talked about this yet. Log base 4 of negative 2. Okay, well, let's write it like this. 4 to what power is negative 2? That's a tricky one. We have not talked about this yet, okay? Well, what can I raise 4 to? Now, if I gave you this right here, 4 to the x, what can I plug in for x and get negative 2? Negative what? Negative half? Well, that's a good guess. 4 to the negative half. Okay. Well, what we have here, 4 to the positive half is 2, and be careful. It's not because half of 4 is 2, it's because 4 to the half power means the square root of 4, which is 2. But, and you're making the mistake that, and I'm glad you said that. You're making the mistake that almost everybody makes, okay? A negative exponent doesn't make it negative. It makes it 1 over that. Remember, 5 squared is 25. 5 to the negative second. Students always think, oh, it's negative 25. No, it's not. It's 1 over 25. Okay? Why this is tricky is this. Where's my notes right there? If I ask you to graph this, you got to think back to algebra 2 here. 4 to the power of x. If I said y equals 4 to the power of x, that's an exponential function. It's exponential growth because 4 is bigger than 1. If you remember when we graphed those, when does this get down to the x-axis? Never. So when does it get down to negative 2? Never. Okay? You can't take the log of a negative. You can't. Okay? And some students go, it's not a real number. Be careful if you say it's not a real number. Because it's kind of implying what?
That is imaginary.
And it's not even an imaginary number. It's not any kind of number, okay? There's no solution to this. It's nothing. You can't, if you take the log of any negative number, you're going to get an error on a calculator, okay? Now, just real quick here, okay? Look at 16C, okay? Log base 5 of 0. I'm just going to do this one real quick. Log base 5 of 0. 5 to what power is 0? Is it 0?
There's no solution out there.
Right.
0.
Not only can't you take the log of a negative, I should say this. Instead of saying you can't take the log of a negative, what I should be saying is you have to take the log of a what? You can't take the log of 0, because we said, when does this get down to negative 2? No. When does it get down to 0? It never even gets to 0. Okay? So just real quick, if you want to jot that one down, 16C is also no solution. You cannot take the log of a negative or 0. It's not a number. D. Okay? This one looks tough. It's actually really, really simple. Log base 7 of 7 squared. I'm going to write it down, and then let's do this. Let's rewrite it, okay? Let's write it without logs. Our base is 7. 7 to what power is going to equal 7 squared? The answer's in the question.
It's square.
2. 7 to what power? 7 squared. 2. It's the number 2. This is the number 2. Okay? E. This also looks kind of confusing. It's actually really, really simple. 3 to the log base 3 of 8. 3 to the log base 3 of 8. Okay? I know you see the word log in there, okay? Just put this question on hold. If I give you this right here, 5 squared is 25. We all know that. 5 squared is 25. If I used to write that with logs, you would say the log, what's my base here? The 5, the 2, or the 25? What's our base? 5. I want to make sure we haven't forgotten this. What is a base? What is a base? Whatever's raised to the power. Your base is 5, okay? So, log base 5 of 25 equals 2. Log base 5 of 25 is 2. So, let's do this. Let's write this with logs. Even though I see a log there, I see a base and an exponent, okay? So the log, my base here is 3 of something equals the exponent. What does it have to be? What has to go in the circle? 8. It's just 8. They just cancel each other out. Just watch these. Hopefully knock these two out real fast. What's 7 to the log base 7 of W?
7 log.
W. See how 3 log base 3 of 8? It's just 8. 7 log base 7 of W is W. How about 12 log base 12 of 19? It's just 19. Now, what if it was 12 to the log base 8 of 19? That's significantly tougher. Don't worry about that. Okay? F. One more of these types of questions, right? Nope, two more. This one, hopefully, you can knock out real fast. What is the log base 5 of 125? It's a nice number. Well, let's try this. 5 to some power is 125. What's that? Good guess. 5. You're gonna prove yourself wrong here. 5 times 5 times 5 times 5 times 5. What's 5 times 5? 25. What's 25 times 5? What's 5 quarters? It's only 3. You want to keep going? No, it's 3. And G, log base 4 of 116. Okay. This is what Lotus kind of brought up inadvertently a few minutes ago, okay? Kind of think about what we were talking about when she said something and I did an example. Let's write this as a base and a power. 4, some power is 116. Well, if it was 16, it'd be what? 4. Careful, not 4 times 4, 2.
So it's negative.
So it's negative 2 because it's 116. This is the number negative 2. Because 4 to the negative second is 116. Okay. Let's do one more of these multi-step ones, and we'll do some single-step ones. The farthest we're going to go is number 33, and we may not, or 34, and we may not even go that far. We'll see. Okay. Number 17. Okay, 10. We've already done this question. To the log of 3. I don't see a base right here. What is it? 10. So what's the answer? What's 10 to the log base 10 of 3? What is it? 3. What work do you expect to see on that one? None. No work at all.
Are we going to have the same question about,
What is it, line, is that what it is? LN? Why you
Oh, I might do that.
Because you can write very cursive.
That's right. Log of 10 to the 5th. Okay? Just put this, write it down and then put this question on hold right here, okay? The log of 10. What's the log of 10? What's my base here again? 10. What's the log of 10 then? What's the log base 10 of 10?
1.
Why? And don't say multiplier times. Because 10
to the first?
to the first is 10. What's the log of 100? 2. Why?
That's 10 to the second.
10 to the second power is 2. Or 100. I'm sorry, 100. What's the log of 1,000? 3. Why?
That's 10 to the third.
He's not wrong. I want to see if somebody can think of a quicker way of saying that, though.
Well, every
How
time
about
you-
this? What's the log
4. No, hold on.
of a billion?
9.
Why?
The amount of zeros.
9 zeros. It's that easy,
If the other-
okay?
if the amount is zero.
Now, if there's a 4 here, you can't do that anymore. But the common log of a 1 with zeros is the number of zeros. That's all it is, okay? So, what's the log of 10 to the 5th? 10 to the 5th is a 1 with 5 zeros. So this is what?
10 to 5 zeros and 5.
Right, so it'll be 5. That's 5 zeros. What's the log of 100? I already did it. 2. Why? You could say because 10 squared is 100. Simpler answer is 2 zeros. Okay, the log of point, was it 3 zeros? 1, 1, 2, 0.0001. I'm going to write it like this. That's the same as 1 over tenths, hundreds, thousands, 10,000s. Well, what if it was the log of 10,000?
Negative 4.
Why'd you say negative?
Because you gotta get those.
Right. Answer this. Quit looking at that. What's the log of 10,000?
4.
Why?
Yes.
4 zeros. So 1 over 10,000 is, bless you. E. E to the ln 2. All right. Well, if it makes it easier for you, that's the same as e to the log base e of 2. We've already done this a couple times. What is that? What? You're making it way too hard. It's no different than this one. Yeah. E to the log base e of 2 is just 2. Just like 3 to the log base 3, they're the same bases. They're the same bases. They're the same basis, so the answer is 2. Okay, and F. Natural log of e to the negative third. Well, it makes it easier, write the log base e of e to the negative 3. Any guesses? Again, this is a real quick, easy one. It's just negative 3. And G. Don't worry about that one. I'm not going to do that one. Okay. Oh, one more thing, real quick.
That one looks super.
Yeah, it's a little more difficult. It's not too bad though. But I'm not going to ask you one like that on a test. I told you on Friday what E was. E is approximately 2.71. I want to make sure you at least understand where that comes. It's not like they're just saying, well, that's just what it is. It's kind of like, I mean, what's pi? About now. I'm just curious. Do you guys know where they came up with that? Did somebody just say, well, let's just make this funky looking symbol equal 3.14 just because I like the numbers 3.14?
No.
No. And anybody know where that came from?
The Mayans did math.
Okay, you got to do better than that.
It's probably on the history of mathematics.
We'll do some trig here. Basic trig, okay? Actually, this is it, really geometry, okay? You guys remember, check your geometry on this. Actually, it was even before geometry. It was back in middle school. Do you guys remember the formula for circumference of a circle?
R
C equals
R squared.
pi r squared is the area. I always thought it was neat with the circles because A equals pi r squared. Circumference, it has a pi and an r and a 2, but
It's 2 pi.
it's 2 pi r. You just move the 2 out front. And twice the radius is something called the diameter. A radius, if you remember, goes from the center to the edge. All the way across is the diameter. So instead of saying 2 pi r, twice the radius is the diameter. So the diameter times pi. Solve that for pi. How do I get pi by itself here? Divide by what? And what does C and D stand for? Circumference, diameter. So where do they get 3.14 from? If you take the distance around a circle and divide by across the circle, you get 3.14-ish. Always. I don't care if it's a big circle or a little tiny circle, okay? Take this little circle, divide by the distance across it, you always get about 3.14. Always. Doesn't matter how big or how small the circle is, okay? And it seems weird because some students say, well, this is really small. It's got to be smaller. Well, the distance around is smaller, but the distance across is smaller. And that's no different than this. This number's small, this number's small. Which of those fractions is smaller? They're the same. Okay? They're both a half. Okay? That's how you get pi. You take the distance distance around a circle, divide by the distance across the circle. Where the heck does E come from? I'm not going to make you memorize this. Okay? Here's what you do. You take 1 plus 1 over x to the x power. Okay? And what do you plug in for x? Whatever you want. But the bigger number, the better, the closer it gets. It's kind of like if I ask you your age. How old are you, 17? Now, I'm willing to bet you're not exactly 17 years old. What if it's your birthday today? Happy birthday. If that's your birthday, then are you exactly 17 years old? Really? I disagree.
No.
Unless you were born at 12:30 and 50 seconds. What? Even then, though?
No,
Because by the time I say it, she's already old. I mean, how accurate can I be? As accurate as I want. To the second? Can I get more accurate to the second? Yeah, tenths of seconds, hundreds of seconds, millions of seconds. You can be as accurate as you want. Okay? The farther along I go, the closer I get to her actual age, okay? But she's only going to be 17 for not even a blink of an eye. An instant, which you can't even measure an instant, okay? What I'm getting at, though, is this. The bigger, like if I was to plug in 1, we'd have, for both of these x's, you have 1 plus 1 over 1 to the 1 power. These are both 1. 1 over 1 is 1, plus 1 is 2. 2 to the first is 2. If I was to plug in 2, it'd be 1 plus 1 over 2 to the power of 2. 1 plus a half is 1.5. 1.5 squared is 2.25. It got a little bit bigger. Okay? I'm not going to go any further because I can't do the calculating in my head. If I was to plug in 10 for the x's, that'd be better. If I was to plug in 100, that'd be even better yet. If I was to plug in 1 billion, that'd be even better yet. If I keep getting bigger and bigger numbers, you're going to get very, very close to 2.71. Very close. It's going to be 2.71, and then it keeps on going just like pi does. That's as far as I've memorized it. Okay? So anyhow, just want you to understand. If you're thinking, well, E, I mean, E is something that's used a lot in higher level math. A lot, especially if you get into calculus, okay? So what I want you to get is this. E is about 2.71. How do they get it? This, as x gets really, really big. How big? As big as you want, the bigger the better. Okay? So that's what I was going to tell you on Friday, but I didn't have time. Okay. All right, on to number 19. Let's actually use this information to solve some of these. You guys are going to like number 19. That's not sarcasm, okay? It says the log base 4 of x equals the log base 4 of 8 minus x, okay? Now, I want to say this the right way, okay? I don't want to confuse people, but I also want to say it correctly, okay? Some students might say, well, we can just divide each side by the log base 4. Not to make fun, but that doesn't make sense, okay? It's kind of like this. You guys got your phones, okay? Do me a favor. Punch in the square root. Type in the square root.
Have to find it too.
Actually, you shouldn't have to. Listen to what I'm asking you. Type in the square root. What'd you say? Of what?
Yeah.
You don't know what to type in. Or how about this? I want you to add together. Get your calculators. Okay, add this up for me. Add up 6.
And what?
Very good. Okay? Unless I give you another number, you can't add. Okay, there's a log button on your calculator. Take the log. Of what? It doesn't make sense to say divide by the log of 4. It's kind of like this. If I gave you this right here, if I gave you this and said solve this, you guys would minus the 1. You have radical x is 6. Are we all done? No, we still have to get rid of what? The radical, okay? Watch carefully. It'd be like, okay, I need to get rid of radical, got to get rid of it, so I'm gonna divide by radical. Hopefully you're looking at it going, what the heck is he doing, okay? That doesn't make sense. That doesn't even make sense, okay? A logarithm is telling you to do something. It's saying find the exponent, okay? A log is an action. So after saying all of that, let's make it real simple. You're not going to divide by the log base 4, but if you have a log base 4 here and a log base 4 here, you know what you can do? You just kind of get rid of them. So you know what I'm going to write down? X equals what? 8 minus x, okay? I'm going to add x to each side. 2x equals 8, divide by 2, x is 4.
Got it.
Now, what if it was a log base 4 and a log base 7? Then it's quite a bit tougher. Don't worry about that right now, okay? It's quite a bit
We're
tougher.
gonna have to worry about it sometime, 'cause now I know.
I don't know about this year.
Okay, good.
Got it.
Well, if I'm gonna have to worry about it next year, I ain't taking it.
Got it.
21.
Huh?
You see the 2x.
Okay, I'm not going to write the original, well, yeah. Log base 5 of x minus 2 equals the log base 5 of 3x plus 7.
So you're gonna do X.
So I'm going to do x minus 2 equals 3x plus 7. Okay? And then I'm going to subtract an x from each side. So negative 2 equals 2x plus 7. Minus the 7 from each side. Negative 9 is 2x. 2. Okay. Let me make sure I wrote that down right. 21, x minus 2, 3x plus 7. X minus 2, 3x plus 7. It's 2x. Okay, good. All right. Something we haven't talked about yet. Actually, we kind of talked about it earlier. Kind of. Okay? While you're copying this down, okay, and there's really nothing new here, okay? Before we move on to 23, just so you understand, we weren't done with number 19. We kind of weren't done with number 19. Kind of. Here's what I mean.
Plug it back in.
You really need to check your answer. If I was to plug in 4, the log base 4 of 4, is that okay?
Okay.
Why? You're right, why? What if that was negative 4, is that okay? You can't take the log of a negative. Is 4 okay right here?
Yeah.
8 minus 4 is 4. We're good. So what should we do here?
Plug it in.
Plug it in, check it. Negative 4.5, take away 2 more. What'd you say?
Negative
Stop right there. She said negative. As soon as she said negative, you know what? I don't care what she says after that. So what does that tell you? Where's our mistake? Nowhere. But when we plug in negative 4.5, we get a negative answer. So what does that tell you?
There's no solution.
There's no solution to that. You gotta check your answers, okay? You can't take the log of a negative. We didn't make any mistake, there just is no solution. It's kind of like asking, when are Cal and Max Bigelow going to have different birthdays? Never. They're always going to have the same birthday. They always will. 23. Okay. Log of x squared equals the log of 3x minus 2. Okay, so, do they have the same base? Yeah, they're both base what? 10, common log. So I'm going to write down x squared equals negative 3x, take away 2. Let's go back to algebra 2 here. Now what are we going to do? And why? Not yet. Nobody remembers this? Uh-oh. This is the big one. Did this a lot in algebra 2. I'm going to add 3x to each side, and I'm going to add 2 to each side. Why? Why? Has to equal 0? Yes, it does. Why? Quadratics have to equal 0. They got to equal 0. So we have x squared plus 3x plus 2 equals 0. Why didn't I make this one 0? It's not a quadratic. There's no squares. Quadratics have to equal 0. Then what? What are you doing? Factor. This is an easy one to factor. X and x, no negatives. There's only one way to times to get 2. Does that work? They don't just times to 2. They add to 3. What does it look like our answers are? Did you guys catch what I said there? What does it look like our answers are? Well, hang on. I want to be very clear here. I didn't say your answers can't be negative. What I'm saying is when you plug them in, it can't result in making a negative number, okay? So for example, negative 2. What's negative 2 squared? What's negative 2 times itself? 4. Is that okay?
Yeah.
Plug in negative 2 here. Negative 3 times negative 2 is 6. 6 minus 2 is 4. So we're good with negative 2. Let's try negative 1. Negative 1 squared is 1. That's good. Negative 3 times negative 1 is 3. Minus 2 is 1. So which is it? Both. Your answers can be negative, but you can't plug them in and end up with a negative that you're taking the log of. Two more, then this worksheet. We're only going to go as far as 28. 25. So cross off 29 on now. Okay? It's 25. Log base 9 of x is 3/2. Okay. I'm going to say this several more times over the next. Yes, ma'am.
That's 27.
Oh, okay. Whoops. Thank you. I'll do this. 25. Log base 3. Good. 25 is easier. I should do 25 before 27 anyhow. Okay. 29, 27. Yeah, that's as far as we're going to go. All right, so let's do 25 first. I'm going to say this many, many times over the next week or so. If you're struggling with logs, write it without logs. Okay, so how can I write that without logs? What's our base raised to what power equals what? And once you do this, this is a very simple question. Our base is what? 3 to the what? Second equals what? What is 3 squared? And I'm not going to explain the rest of this. You can't finish this out. Good gosh. Is 13 good? I want to be very clear here again. If we got an answer of 1, 1 is positive. Would 1 be okay? Why? 1 minus 4 is negative. So just because your answer is positive doesn't mean it's good. Just like because your answer is negative doesn't mean it's not good. 13 is okay because 13 minus 4 is positive. Okay? 27. Write it without logs. 9 to the 3x power equals x. If you're not sure what 9 to the 3/2 power is, rewrite it, okay? I'm gonna say this, I think some of you guys know what I'm talking about, tipping the thing over. You guys remember that stupid thing? I do this. 9 to the 3/2 power is the second root of 9 cubed. The way I explain it, whatever's last is first. Remember that?
Yeah, whatever's first.
And then you guys remember some students like to tip it over and they know what that talks about, and I don't know what the heck you're talking about. So if you get, I don't care how you do it as long as it's going. So this right here is the second or square root of 9 cubed.
You can't just like see the.
I just don't see it. Just like I don't know what the libero is in volleyball. And I know she's gonna try to tell me again what it is, and I don't know what it is. I'll never know
We
what
need
it
to
is.
get like 2 cubes stapled together, just write it for you and show you.
It ain't gonna matter. I just can't see it.
I can't see it.
I know the libero was a white shirt, and that's all I know. The square root of 9 is 3. Cubed is 27. Okay. Questions on this? Okay, so tomorrow will be a work day, and I think Wednesday's a work day. Then we're gonna start new stuff on Thursday.